You all for coming, man. This is like a great turnout. I'm really excited. A lot of familiar faces, a lot of new faces, faces of people I formerly worked with, faces of people I currently work with, and people I've met at other meetups. So I'm just, thank you for coming out, man. And big thank you to Zach for breathing new life into this meetup. Like, this thing had been like puttering off. He took it over, did some presentations. Now it's like a monthly thing, and I'm excited about it being, I'm really excited about AWS. So, I'm excited about being part of this. So thanks for the opportunity, man.
Oh, well, thanks for, Steve Jobs definitely taking this on. I see you. But I was just blown away. For all the food, all the orchestration, it helps because I've been kind of doing this for the past couple of times on my own. But when the community kind of gets involved and takes charge as well, it's just amazing. And Jordan, thanks so much for volunteering for this. Jordan reached out. I believe it was right after I took over the AWS meetup. Jordan already reached out and said, "Hey, I'd love to volunteer." So within, I think that was within like half an hour.
I got the email and I was like,
so thank you just for being in the community and taking this initiative. So I'm going to sit back and just truly.
Yeah, you get to relax for once, man. You get to kind of take it easy, kick back, dude. Yeah, absolutely. So the title I hastily prepared was Container Deployment Architectures in AWS with AWS EC2 Container Service. And I sent that to Zach. And as I've been working on it, I actually did a little bit of snooping. I don't know if a lot of you may have noticed your recently viewed LinkedIn profile person was me. I was checking you guys out. I wanted to kind of get an idea what my audience was and what the level of experience was here. So, and kind of what I discovered was we've got some really, really experienced people who could probably be doing this presentation. Some people have been in software engineering for 30, 40 years or more even. We've also got some people fresh out of college. So I kind of refactored the presentation a little bit. I'm still going to be going over ECS. I'm still going to be doing a demo in ECS, a lot of the same concepts, all that kind of stuff. But I've changed the title to Practical Container Orchestration in AWS with AWS ECS. So instead of focusing more on like high-level architectures, I want to go into more like best practices and practical kind of principles, things you can apply when using an orchestration solution, even if it's not ECS. And then I want to show you guys a demo of how you can actually apply those in action with ECS. So, and so to be covered, I'm going to briefly go over some of the basics, like what are Docker containers, and then I'm going to talk about what container orchestration is, which is what EC2 Container Service is. It's an orchestration tool. And then I'll go over some of the concepts of ECS and some best practices. And then I'll have like a demo for you guys so you can just kind of sit back and enjoy the show and hope my code works. But before I even get into Docker, I want to talk about the direction of software engineering and the cloud and all this kind of stuff, because I think it's important to understand like kind of where we came from and where everything's going. And so in the past, the generic or standard architecture was just monolithic application that was deployed, typically on a single server and maybe replicated across some others and then load balanced. And that was the old way of doing things. And that was largely the result of what was available to us in terms of our infrastructure. So we were using rack space, or I had a server room in my own company. And if I wanted to deploy to a new server or something like that, we had to order a new server. It would take potentially a month. We had to set it up and configure it manually. That would take like a lot of time. And now with AWS cloud computing, like that's been drastically changed. The landscape has changed. And now, we have on-demand servers instantly as soon as we want them. Within a minute's time, we've got a box for us. And what that enables really in this transition that's going to happen is this move towards a microservice-based architecture that really takes advantage of loosely coupled services, spread across many different hosts, and a real kind of service-oriented architecture in like a more true or perfect form. And so this is kind of where we're going, and AWS or other cloud providers are really the vehicle to kind of get there. So we talk about, to keep it simple stupid with containers, why containers are really a big part of what empowers microservices and microservice deployments. Containers make it able for, or Docker containers is what I'm going to be talking about here, make it possible for our engineers to develop in an environment that's similar to production and kind of stand up that environment locally, and they can have a pretty good level of confidence that what they're developing against locally is going to be very similar to what's going out in production. The only difference really would be the operating system potentially that they're running locally may be different than what they're running in production. But the environment is essentially very similar. So the way I like to talk about Docker containers and the way I like to think about it is I consider a container basically wrapping an environment around a process. So whereas with virtual machines, you may have many processes running or whatever, I like to think of it as trying in the most simplest and most perfect form. A Docker container is wrapping an environment around a process, and that includes any dependencies that process needs and nothing extra. So you want to keep your containers as lightweight as possible. And containers with Docker, there's no kernel included. So you may be able to run an Ubuntu virtual machine on a Windows host, but you cannot run an Ubuntu virtual machine, an Ubuntu container, Ubuntu-based Docker container on a Windows host unless you virtualize some other layer. So to compare the two, one of the big advantages of containers versus virtual machines is simply they're lighter weight. And you have a lot less lower memory constraints, and it allows you to more efficiently kind of deploy your applications. Another big piece is that containers start up, virtually instantly. When we boot a container, it's usually less than a second, sometimes less than 100 milliseconds to start a container. Whereas with a virtual machine, you've got to wait a long time, and that makes developing less efficient. And since we can develop locally with containers, that start time really empowers our developers to continue to develop kind of against production-like deployment scenario without having to worry about kind of cycling a virtual machine. So does anybody have any questions? Anybody can feel free to raise your hand or interrupt me if I'm talking too fast or anything like that. Container orchestration, this is what EC2 Container Service provides to us as a tool. And basically, when we talk about container orchestration, it's basically managing deployment of containers at scale, across all of our infrastructure. In Amazon, it's a bunch of EC2 instances that are kind of part of a cluster. So when we're looking for a container orchestration tool, there's a set of features that we kind of would expect in order for it to work. So ECS would provide more or less this base feature set, and so would Kubernetes or Docker Swarm or some of the other competitors. So the important features really are the scheduling, which is how the tool figures out what container gets deployed on what machine. And that rule set, how it figures out where they go, is based on your own configuration. And depending on what you choose, your configuration, depending on what products you're using, the extensibility or how much you configure, how granular you can get about where containers are placed, it just depends. Health checks when your containers are deployed, this tool needs to be aware of when they die so that it can reschedule them in a new place. It can put them on a new host. And finally, service discovery is another important piece. One of the complexities of deploying microservices is that there's a lot of different services that need to communicate. They're deployed across many hosts potentially and redundantly, and it can be difficult to deploy them in such a way that they know how to communicate with one another. You don't know what IP address and what port they're necessarily going to come up on. It could be a dynamic port, or it could be depending on your configuration. So service discovery is the mechanism that basically provides, often through orchestration tools, provides you the ability to figure out how do I get to my services and how do my services communicate with one another. So a lot of orchestration tools will offer that. Some don't, but their same company, for example, HashiCorp, offers something called Console, which, go ahead, Yoko, go ahead.
Deploy time or?
The service discovery?
Yeah.
So it depends on how the tool works. Like with Amazon, with ECS, when a service is deployed or a new container is deployed, it gets added to a load balancer. That's its version of service discovery. Other tools like Kubernetes have multiple options, one of which is Kubernetes can act as almost like a DNS server, and it can hold service records or whatever, and you can actually do lookups against that kind of DNS server to discover services. Or it can act as like a proxy, and it adds, which is kind of like a load balancer in the same way, and so it can add that service to a load balancer. It'll proxy traffic to the new services. So there's configurability depending on the solution you choose. But yeah, good question. Another important piece is obviously rolling deployments. Me as a DevOps engineer, my job is to empower my engineers at my company, help them push code and deploy it quickly, and be able to debug their code and push fixes. And so managing deployments across a cluster of servers for a particular service can be complicated. And an orchestration tool will offer some sort of feature to allow you to roll out new versions or roll back to a previous version quickly. And a lot of them have various different scenarios, so they can kind of do like a blue-green deployment, or start sending a percentage of traffic to this new version, and if it starts going well, then start incrementing more and more traffic. These are it just depends on the tool you're using and what your offering is. ECS doesn't really do that. ECS is a little bit more simplistic with this approach. And finally, monitoring, not of all the hosts in your cluster, but monitoring of your containers. Devs want to know if their container is running really hot, it's using up a bunch of CPU. They want to know what the memory utilization of the containers are. So they want insight, and they need insight into what's actually going on in order to troubleshoot, and they need to be able to kind of profile their existing running infrastructure. So at the very least, your orchestration tool should offer some sort of insight into the performance of your running containers. And the last piece is some of them offer some sort of solution for secret management. Secret management is just complicated in general, and there's entire tools dedicated to dealing with this complexity. AWS ECS offers its own kind of version specifically for Amazon permissions, Amazon secrets, to address some problems with that. So I'll get into that later. Does anybody else have any other questions? Okay.
Yeah, how are resources like processing time allocated to containers? Like if I have a container, something deployed on there, it's running slow, how do I know that it's not something else on a host that is not within my own container? Right.
Great question. So with ECS, for instance, there's something called a container definition. That is kind of what you specify a minimum number of resources that should be reserved specifically for this task or this container that's being deployed. And so you can specify, I want, say, and it goes in with Docker, they kind of have this notion of compute units or whatever, and you can say, I want this many compute units reserved for this container. Generally speaking, the way I've done it is, unless it's like generally speaking, the way I've done it is I don't specify it, which allows all the containers that are deployed there to have full reign to go to full utilization or to no, and I just scale quickly. And I try to scale up to deal with the incoming demand. But you definitely could, particularly for like supercritical services, you can reserve a base level of compute in Amazon that has to do with these CPU units. This is how Docker frames it, and they will be reserved specifically for that task.
I know container support is we're using regular, we have an ELB with regular EC2s behind it.
Mm-hmm.
And it has the potential to auto-scale and
great, yeah. Right. And depending on the tool, so some of them have their own built-in scaling that kind of, for instance, Kubernetes has built-in scaling, and it would just interface with the Amazon API and just tell its own cluster to become bigger. ECS, I'll talk about it later, but it uses scaling through CloudWatch, similar to you use with an auto-scaling group. It's the same thing, and you scale more containers up, and you have kind of pretty granular controls of how to scale containers independently and your cluster, like independently. So these are the options. There's a lot of competition because there's so much momentum going this direction, and so there's like a dozen, and this isn't all of them, container orchestration solutions. And one thing that's starting to happen is that, for instance, Google Container Engine is the kind of Google's direct competitor to ECS, and it's basically a wraparound Kubernetes, and they just kind of provide Kubernetes as a service. And so Rancher kind of has done the same thing. So there's actually different layers of abstraction to kind of remove the complexity of deploying your own cluster, because it can be complicated to deploy your own orchestration tool. Now I want to get in more like into ECS, and I pulled this directly from their page, and I wouldn't really read it to you, except I just wanted to say, like, they say it's a highly scalable, high performance container management service that supports Docker containers. But that doesn't separate ECS from any of the competitors. Every single one of those previous options does that exact same thing. So ECS doesn't really gain any benefits over the competition for that purpose. But the second sentence really is an important distinction between ECS and competitors particularly when you're deploying on Amazon, is that it eliminates the need for you to install, operate, and scale your own cluster management infrastructure. So if you deploy Kubernetes in Amazon, I believe it's a minimum of 5 nodes just to run Kubernetes. And those nodes aren't actually taking containers and or deploying your application. Those nodes are just for Kubernetes to be resilient, fault tolerant, handle all the proxying of requests, whatever it needs to deploy your infrastructure. So you have to pay for those 5 nodes, and you have to manage them. And if you have multiple environments, then that could be 5, 10, 15, or 20 separate new reasonably sized instances that now you have to maintain. So that's a significant amount of effort. With ECS, it's a service. So it's similar to like RDS for databases, in that you don't have to manage all the stuff that's going on in the background that's doing all the work and is deploying your tasks and monitoring your containers. That's all kind of handled by Amazon. And so that's really the biggest advantage for AWS. The other piece is that it's free. You don't have to pay for those servers now because Amazon's doing it for you. You still have to pay for the instances you're deploying to. So you're deploying your application, you're still paying for those. But the service itself is free. And I put ish because there is a trade-off, there's a sacrifice you make. It just further couples you to Amazon, right? It's another Amazon managed service you're using. If you wanted to lift and go over to Google, that's another thing you have to move. But I personally am not a fan of that argument, and I've heard it made. And the reason why I'm not is because, as far as I'm concerned, like, I'm already like completely stuck on Amazon. Like, everything that's deployed is already on Amazon, and that's using Amazon specific APIs, Amazon specific permissions. Like, if you want to move to Google, unless you have a really basic infrastructure, like if you started to use any of these Amazon services, you're like stuck, and it's going to be a huge amount of effort. And so the extra effort to like get out of ECS is to me like inconsequential. The only scenario where I would definitely say you would want to not use ECS is if you were trying to do hybrid cloud and you wanted to run half your services in Google and half your services, in Amazon. Because usually when Amazon goes down, like a whole region goes down. It's not just an availability zone. So in that scenario, like a hybrid cloud approach would be, you couldn't use ECS for that because it simply won't work. But ECS is easier to reason about. It's a less of a learning curve. Anybody here, or a lot of you have a lot of experience with Amazon. Even if you have a moderate amount of experience with Amazon, like, it's expanding on concepts with AWS that we're already familiar with. So it uses elastic load balancers, and it uses them for service discovery. We already understand what an elastic load balancer is, what its purpose is. So it's easy to understand and to like tie that in and work with your existing kind of deployments. Also, like auto scaling groups, that's how it manages scaling of the cluster. And CloudWatch, that's how it manages all of its monitoring. And CloudWatch also is used for scaling too. So it's the same type of thing that you're doing when you're only deploying the EC2 instances. When you move to ECS, you're just doing it using the same kind of services. So it's not that much of a leap. You don't have a total new configuration to manage your scaling or whatever else. And a really big win with ECS is that it supports IAM, Identity Access Management roles. So this is how Amazon manages its permissions. And what Amazon, or what they recommend when we typically do deployments on a standard EC2 instance, is we attach a profile to that instance. When we're running in that instance, we query basically Amazon and say, hey, give me permissions, give me credentials. Amazon returns us temporary keys that we can use to access other AWS resources. So if I know I'm deploying a particular user service on an instance, I put the user's profile on it, and now the user service can query its own permissions and use those to access other AWS resources. So when we start dealing with containers, we're talking about deploying numerous services on one instance. That's one of the big advantages that allows us to stack them. And we can stack them to really efficiently utilize our infrastructure. And so we have to run fewer instances. But if we have one profile per instance, now how do we manage permissions? Now all of those containers could potentially access the same permissions. And so we have to merge the permissions. It just gets complicated. So AWS fixes that problem with ECS, and you can attach a role to a particular container basically. And so that container only has permissions to what it's supposed to have and nothing else. If you go with some other solution, you're going to have to go through some other, and I'm sure it's been solved, but you're going to have to work with whatever their solution is. And with ECS, you don't even have to change your code. The Amazon SDK that you're coding with to get permissions, literally it just works. You can just go from an instance to a container and deploy with ECS, and the permissions will be fetched the exact same way. So it's transparent to your engineers. Any other questions? Yo, Jason?
Is it possible for a container to migrate off of a failing Docker host instance?
Sure. So you would have to detect the failure, but ECS has something called instance draining, and it was added. I don't remember how long ago it was added. It was added not that long ago. But basically, you can drain an instance in preparation for, say, maintenance. You're going to terminate it for some reason or for whatever reason. So if you detect that that instance is having problems, that your containers that are deployed on it may still be receiving traffic. So you don't want to just kill it because there may be a brief blip where they're receiving traffic that they can't return now. So the solution is to drain the instance first, and then that will actually stop sending traffic to it. It'll give time for the existing connections to close, and you specify that time frame, and then it will migrate the services off of that instance to a new one that's healthy. So that's how you would handle that. I have never configured anything that auto-detects an instance that's got problems and done that, but it's definitely possible because CloudWatch is your mechanism for monitoring. So, and CloudWatch can kick off, I've done it, can kick off draining basically through like a what's called a Lambda execution. So you can hook all of that up if you wanted. Anybody else? Multiple Docker containers, absolutely. Yeah, yeah. As many as it'll fit. And yeah, so like when I like to think, when you think about an ECS cluster, it's a bunch of hosts that are all kind of registered with ECS, and they're saying, hey, I'll accept containers. And when we specify containers, we say, hey, this container needs a minimum of say this much memory. So if I say this container needs 500 megabytes of memory, and this host I know has 8 gigabytes, it can deploy more or less about 8 of those containers on that host before it's going to realize it can't fit anymore. You know, so you specify that, and you just kind of let ECS and its scheduler figure out where the best way to allocate those containers across those hosts. No, only Linux. Yeah, sorry, haven't tried it. Yeah.
So could you potentially have your containers running on the same physical piece of hardware as someone else's containers, or are you actually purchasing?
Well, that's a really good question. So AWS has the concept of dedicated hosts, which is what gives you like a guaranteed instance that's not shared at all. So your container is going to be on just your virtual machine, but unless you have a dedicated host, somebody else could have another virtual machine running on that same hardware. Yeah. Right. And certain, certain types of compliance. I learned this from Zach actually, because his old company, they had HIPAA compliant, and they had to use dedicated hosts. They removed that. So you used to have to do that. You don't need to do that anymore. Yeah. Yeah. Yeah, it costs way more. Good question, man. Yeah, instead of like 12 or 11. Yeah. Good question, man. So in terms of ECS concepts, because I'm going to be doing a demo, and I want you guys to kind of see how ECS works, and you're going to be seeing this terminology. So I want you to kind of know what it means. So I've been saying the word host. That is basically an EC2 instance that has registered with your cluster and is looking to accept containers. And the way it works is that ECS and Docker is installed on it, and it's running an agent. And that agent is what communicates with ECS. And then a cluster is just 1 to n number of hosts that are, who are part of the same namespace. So when you register your host, you're registering under a particular namespace. So we can run multiple clusters. And we don't have to worry about containers being placed across those clusters. That's a good way to separate those concerns. So if we have potentially a batch job that spikes up a bunch of load and we don't want to worry about messing with our, production, like, APIs that are serving traffic, we can run that on a whole separate cluster. Any questions? Nope, okay. So the container definition, I talked about that. That's what you asked about, Jonathan. That's what specifies specific details on how to execute this container. So that's CPU, memory, environment variables, logging configuration for centralized logging, and it supports most Docker run parameters at the ECS. There is a limitation with ECS in that Docker releases new features, it's proprietary. Amazon now has to see that new feature and then work it into its existing kind of code base. And so there's actually certain run parameters that aren't supported, and I know that there's open feature requests for, but you get hung up by that. I've been hung up by that, and I was able to work around it, but it wasn't exactly elegant. So keep that in mind. But overall, most, I mean, you're not going to run into this very often unless you have a pretty particular use case. And then the task is the same thing as a Kubernetes pod, basically. It is 1 to 10 container definitions deployed as one piece. So if you have 2 containers that need to be deployed together so they can communicate locally, so they can have like high performance, or maybe they're just tightly coupled and you just don't have time to break them apart, you can deploy them as a pair on every single host, and so they'll never get deployed separated. And an important piece of tasks is that they are both versioned and they're immutable. So if you roll out a new version of one of those containers and it breaks, and you just know that your service is broken, because a task is supposed to represent like an application or a service. It's a collection of things that have to be deployed together. One of those broke, but you don't know which one. You can easily just roll back the whole task, and so you don't have to worry about which container broke the version and which service I need to roll back. It just rolls them back as in total. So that's one advantage of tasks. And then the service is what does all the magic. When you go into the ECS console, and I'll show you guys later, this is what does, manages kind of and communicates with the Elastic Load Balancer and with your agent kind of, and it's kind of like what manages the service discovery, it manages container health, manages the deployments, and it does all the scheduling. And I talked about scheduling and how different types of container orchestration tools offer different kind of features with scheduling. ECS, I only mentioned this because this came out last December. So brief history, ECS is kind of newer in the game. It's kind of behind the times. It's been playing catch up for a while. Kubernetes is open source, has a lot of momentum behind it, has got Google behind it. So there were a lot of features that were in Kubernetes and in Docker Swarm that ECS didn't support yet. But last year, Amazon invested a lot into ECS, and one of the big features that came out with was called task placement constraints. And those constraints is more than just say, hey, spread my containers out across as many availability zones as possible for redundancy. You can now kind of write SQL-like, it's like a where clause in a SQL statement where you can say, hey, I want it to be deployed on an instance of this type with an instance and also has this tag. You can put parentheses around it, or an instance of this type. So you can get pretty granular with how you want to deploy it. And that's like a pretty powerful tool to use. So that was a limitation that it had, but now you can get about as granular as you could possibly want. Great question. And yeah, they do. Yeah, so they all have access, I believe, to the same credentials. I can't speak to how it's going to work with other tools. Yeah, I don't know. Different orchestration tools like Kubernetes, I believe a lot of people run this thing called like a sidecar approach, which you run this one container that runs on every single host, and now it like holds all the credentials, and then whenever containers start on that host, they like query it somehow and be like, I'm this API or I'm this service, I need credentials, and it like knows which one it is and then returns them. So it's like an extra container you have to run on every host. But I don't know about like in terms of a pod, like if there's multiple containers in the same pod or task, if you could have unique credentials for each one or not. That's something I don't know about. Anybody else? So far, so good? So some best practices with container orchestration tools. One is use the Amazon ECS base AMI. If you're going to use ECS, this is ECS specific. And the reason why you want to do this isn't because it's just convenient. So the ECS base AMI, it basically has Docker installed, a specific version of Docker, and they release new versions of it. It also has the ECS agent already configured. And that's great, that's fine and dandy, but the real benefit of the base AMI is it's tested by Amazon. There are people who would say Docker isn't production ready. And the reason why some people would say that is because they're running on some operating system that has bugs with Docker. Docker has to work on like everything. And so the Docker engine kind of serves as this adapter between the kernel and whatever containers you're running. And so often with IO and IO intensive tasks, people have kind of run into issues with Docker crashing or the whole host crashing, things like that. And so there's actually recommended versions of operating systems you should run Docker on, or sorry, run like your containers on if you want it to be stable. So Amazon kind of handles that for you. They created something called Amazon Linux, which is like a fork of, I think it's Red Hat, and it's Red Hat's. I think it's Red Hat. Yeah, it's like which is similar, same thing. So it's like a fork of like Red Hat, and then you can log in. Or sorry, lost my track. It's like a fork of Red Hat, and then they've actually tested it and verified that like you can run containers. It's reliable. It's good with I/O, all this kind of stuff. So that's like a big benefit. So if you're going to use ECS, I highly recommend using the base AMI. One concern per container, and I really like to say ideally one process. This just makes it a lot easier to troubleshoot and debug. There are containers out there that are on GitHub, and they kind of call them base containers. And what they are is it's like, hey, we have this base container. It runs some sort of supervisor process. And all you got to do is drop your executable in some folder, and then now everything that's in this folder is going to get executed and run as a sub-process of that process. And that works. The problem is there's a few things that make that kind of tricky at times. One, no longer are you encapsulating an environment around a process. It's an environment around many processes. So those processes may have their own particular like requirements. And so now you're just kind of bloating your container a little bit because you're running multiple processes. The other piece is logging with Docker logging driver. Like it kind of gets tricky to get logging right sometimes. So unless you're managing the logging from within each process, like a lot of times getting standard out of that process through the supervisor process and out so that the container Docker log driver will see it. Sometimes you'll have to deal with missing logs. You have to go in there and figure out how to get to work right. So my preference is to always try to deploy, a container that's basically executing a single process, which is basically your app. And it's not a shell command that starts your app. It's literally just your app. So when you attach that container and you run PS, to see what the running processes are, you just see that one. And maybe any sub-processes that your process may have spawned, but just your process is PID1. And I think that's like important, like in terms of just debugging and making it easier to keep track of what's wrong. So one more thing on that, not to like harp on it too much, but these supervisor processes, they often monitor the health of your process, and they'll restart it if it fails. So suppose you've got a container and you're running multiple processes in it. One of them fails, it restarts it. You have no insight into that. As far as your container orchestration tool is concerned, ECS thinks it's healthy. It thinks everything's fine. It's going to keep sending traffic that way, basically, as long as the health checks are passing. So, but it knows the container's running, so it's not going to move it. It's not going to try to handle that in any kind of graceful way. It's going to be completely blind to it, and you're not going to know there's a problem. So if the whole container dies, if you fail fast, whenever you have run out of memory or whatever the problem is, like if it dies immediately, it's easier to troubleshoot, and you have visibility into it, and you can see it, like, and be alerted by it. So that's something I strongly recommend. And also, we talked about the task, and you can have multiple containers per task. I recommend one container per task if you can. It just reduces coupling. So if you have to deploy 6 containers together as one piece, maybe you need to rethink your architecture. Maybe things are a little bit too tightly coupled. So that's a recommendation on my part as well. And another important one is don't Dockerize everything. Not everything belongs in a container. Containers are best for microservice applications. They're best for stateless applications. Databases don't necessarily belong in containers. Maybe you should consider some sort of hosted database service or something like that. That's my opinion. And then the other really important piece is you can't even go down this road until you've got centralized logging for everything, because containers are ephemeral. So you don't know what host it's going to be scheduled to, and if it crashes, you won't be able to get to it by the time it's gone. So you will have no insight into what's happening. So if you don't have centralized logging, don't even start, because it's a waste. It's just a fruitless task. So get your centralized logging configured so you have the ability to actually keep track of what's going on and be able to debug any issues you run into.
What should the developer keep in mind?
Yeah, so that depends on the company and how you'll handle centralized logging. My current favorite approach, I thought about the approach of, hey, all developers send everything to standard out. I'll collect all your logs for you and I'll put them into centralized logging, right? And that approach works. It does get it there, but you sometimes lose out on features like stack traces can get interleaved between different containers and different logs, and you want that logged as a single piece. And the Docker log driver, which is what would be pushing those logs, sees every single line as a single log file and streams it one by one to your logging repo. So that's trouble. And you have to have some sort of other middleman that kind of tries to see where they're coming from and squash it, and it just becomes complicated. So I prefer, exposing some variables like environment variables at the container, on the container level, that the application can see and be like, oh, this is how I get to my centralized logging repository, and then they let the developers handle it. Then they can tag it however they like, and they can search it. They know how to search it. If they want to update the logging format in whatever way, they're empowered that way, rather than kind of being stuck with DevOps kind of handling the logs for them. No, I would have the developers actually stream the logs directly through some sort of library, right? Yeah, I would definitely not write to the local file system. I would definitely have the developers just stream the logs. And I've never had a problem, even with UDP, sending them over UDP with logs really like missing and not being able to find what you need. And then I still stream, as a DevOps engineer, I still stream standard out. So if their application is flapping and it's just starting and crashing, like something's going to be in standard out, that's going to end up in centralized logging. So that's useful for them for debugging. And it's okay if those kind of get interleaved, and because it's not a really common scenario. But in general with developers, like I like to let them just kind of handle it however they want and just stream it. Yeah. Right.
We have another container that's just sitting there listening on all those other containers.
Yeah, sidecar, yeah.
The Docker containers out.
Right.
And then it ships it over to Elasticsearch.
Yeah, that's a common paradigm. Right. And that's okay for managing standard out for like when containers are booting and they're sitting out the standard out before the app starts. But I think as a developer, when I'm writing my software, like I think it's better for the application itself to manage sending the logs. So if you're running like somebody else's container, you're running a RabbitMQ container or whatever, and then if you can configure RabbitMQ to send it to standard out and you ship it, because you're not going to go in there and mess with RabbitMQ, obviously. So just write that to standard out and use your log shipper to ship it. But for the actual engineers on your team that are developing, I prefer to empower them to kind of send the logs themselves. Then they can do whatever unique approach they want in terms of tagging it or whatever. They have control over that. So, any other questions? And the last piece was like write for scale. Zach did a whole presentation on infrastructure as code. So we want to start approaching infrastructure as like software engineers as well, rather than just ops people. So we want to write code for infrastructure. So it's not that much work to write scaling policies. And if you write them once, that's all you need to write them, right? It's basically a function call. So if you want to, scale a particular service, you write the scaling policy once, and you just call that function basically each time, and you attach that scaling policy for everything. So that's I would just say go ahead and do that ahead of time and just get that out there, because later on it's going to be harder to go back and add it once everything's already out there. Another piece is, and I'm going to get to demo soon, guys. Another piece is path-based routing. is an important new feature with ECS. It's actually a application load balancer, which was released last August. I don't know how many of you are familiar with it. Amazon previously had only the standard, now they call it the classic load balancer. It can route traffic on TCP or over HTTP or HTTPS. But they added the application load balancer last August. And it was directly to deal with a couple of issues that were limitations with ECS. One was, well, one's limitation with ECS, the other one's just another feature. One of them, and a really big one, was in the past, you couldn't run multiple containers on the same port on the same host in ECS. So if I had multiple app servers listening on port 80, I couldn't run them on the same host because it wouldn't do dynamic port mapping. And now that's a new feature. So that's a big win. And the other one is path-based routing. If we don't use path-based routing, we're going to need one load balancer for every service that we have and we're deploying. So with path-based routing, that allows us to basically inspect the URL path that's coming in and look at it and then decide what service that traffic needs to go to. So if we just prefix our URLs with a service name, we now know what service to send that traffic to. And now we can have much fewer load balancers, and it just kind of reduces costs and just makes our architecture simpler. Yeah. It is a reverse proxy, right? Right. And behind the scenes, I've heard rumors that it's HA proxy basically that they stand up, but I don't know exactly what the implementation is. But it's a reverse proxy. And so this would be path-based routing the old way with just classic load balancers. So these are containers, and we have a load balancer per container. But if we add an application load balancer, we can inspect the path, and we have one load balancer that sends traffic to all three. Another big benefit of this that's kind of you wouldn't initially notice, but sometimes services have spiky traffic, and a load balancer would scale down because it's not seeing a lot of traffic. If you hit a big traffic spike, you could just knock over the elastic load balancer. And if you're only sending traffic to one service, it might have scaled down to really small because it's receiving none. And it might just fall over as soon as you start sending hundreds of requests per second to it. So if you start spreading it all out across one load balance, the application load balancer, you're going to have a more steady stream of traffic. It's going to be more pre-warmed, essentially. And so it's less likely that any kind of spike to one service is going to just break the load balancer. And the last piece is leverage EFS instead of EBS where possible. So EFS is Elastic File System. This is Amazon's network file system. And EBS is Elastic Block Store. That's the virtual appliance drive you can just mount to any one particular EC2 instance. When we're deploying microservices, we don't know what instance a particular service is going to go to. So how do we know what drive, where to mount the drive? And so then we have to write various scheduling rules to basically force a particular service to start on a particular host so that we can then mount, so they can have access to that drive. So this is an example here. On the left, this blue dot is a service of some sort, and it needs to have this volume available to it, right? So now I have to force the blue one to deploy on this particular host in the cluster. But if I use EFS, I can have this network file system attached to every host, so I don't care where it goes, and I can always access what I need to access and write to what I need to write to. So that's just a common paradigm with container deployment that's important to be aware of. The only real detriment of EFS compared to EBS is just latency. Like, it has a really good write throughput. It's actually really fast. And you only pay for what you use. So if you're mounting a 50 gig EBS file, you're paying for those 50 gigs. But if you only write a few megabytes, you're wasting your money. But with EFS, you're paying for just a few megabytes. You're paying pennies. So you're paying for what you use. So my demo is going to be the sample voting app. This is Docker somebody created this to kind of demonstrate Docker Compose. Docker Compose is how you can stand up kind of and orchestrate containers locally on your local box for development. And it's got 5 pieces, 5 services. It's got a Python web application. It's got a Redis queue. I think the Python one's in Django. Redis is acting as a queue to receive messages. Some sort of .NET worker that consumes messages off that queue, a Postgres database, and a Node.js web application. And so this is the diagram from the repo. And basically, you go to a URL on the web, and you go to the vote app, and you vote for cats or dogs. It'll put a message on a Redis queue. This worker will consume that message, update the database that you voted for cats or dogs, and then you'll see the results in the Node.js app. It's a very simple, minimal architecture, but it's 5 separate containers in this case that would be deployed across our cluster. Here's a sample architecture we could use for this deployment. Basically, we have a cluster. We've got Redis and Postgres in it, and we've got all of our services deployed across it. And Postgres is served by ELB, and so is Redis, and so is the vote and result app. So does anybody any recommendations on how we can improve this architecture? This would totally work. Anything we can do to improve it? Any ideas? Perfect timing, man. You can use an application load balancer with path-based routing, right? So we can put that in there, and we can say, oh, traffic that goes to /vote goes to the vote app, and traffic goes to result goes to the result app. Any other improvements we can make on this? Any other ideas? Go ahead, Jason. Killed it, man. Yeah, it killed it. Any other ideas other than just Postgres? Yeah, get Redis out of there too. Why not? Amazon has a really nice hosted Redis service, last to cache. So we can pull those out, and we can add. Oh, I didn't pull those out. Sorry, I got them mixed up. We can add an auto scaling group around it, so we can scale if we need traffic. So we should add that. And yeah, we can pull out Postgres and Redis, and we can also configure centralized logging, things like that. I wouldn't expect you all to think about that because you couldn't tell from the diagram that was missing. But CloudWatch offers a centralized logging service that's genuinely awful, but it's better than nothing. So you can use that for centralized logging. And then also CloudWatch offers, that's how you scale up your vote and result apps if you like. And it also offers you, gives all the monitoring to you. This is like a network diagram. I wouldn't pay much attention to it. This was actually a presentation. This is something I had to do for a job application. I had to build this VPC and deploy this thing and whatever. So, but basically, this is my implementation, and I had to put Postgres and Redis in the cluster for the implementation. And I also didn't want to have to pay for those because this was all just like, I didn't know I was going to get anything. So basically, with demo, I'm going to be deploying an actual Postgres container in a Redis container, but I don't recommend that. I would use the actual services. All right, so is it Vince or whatever? Okay, so I'm logged into my AWS account. You can see there's no VPCs, there's no containers in EC2. It's going to be a little demo of Terraform. Does anybody here use Terraform? Other than Michael? I know Michael uses it. No one else? CloudFormation, you guys? Everybody's CloudFormation? All right, so I'm going to use Terraform. It's a competitor. It's a HashiCorp product. It's a competitor to CloudFormation. And I really like it. So I'm going to kind of show you guys a demo of this in action. I didn't bring this over here. So this is my configuration. So these are the Terraform files, and this is the container definition. So you can see what a container definition looks like. This is defining that this Postgres database needs 128 units of CPU, 512 megs of memory, or 128 megs of memory, and a maximum memory of 512. What's that? I can just do that. This isn't like perfect, like this is a demo, so I wasn't like going for perfection here, but this just shows you like what the configuration would look like. And this is a standard template. This is just a JSON file. So this is what actually gets passed straight to Amazon via over an API. You just hand them this template. So I think I might be mapping in. Yeah, I'm mapping in like an image name or something like that. But you can with Terraform and all these, you can pass in any kind of variables in here. And these are just kind of the configs to set up the VPC and to set up routing tables. And ECR is an important piece. These are creating ECR repositories. Elastic Container Repository, it's basically Docker Hub, but Amazon's implementation. So you can push your Docker images to there. So I'm going to get the script started. So I wrote just a bash script to wrap it that runs. And it requires a couple of parameters. It's called build and deploy cluster. So it requires my profile name, and it requires, which is personal because it's my personal account, and then an SSH key pair to put on the instance so I can SSH in if I want to. So I'm going to run my script. This is doing cleanup. It's got to rebuild the Docker images, so that's what it's doing now. And then this is Terraform saying, hey, you want me to create these 5 ECR repositories. So the first step, I got to create the repositories, then I got to push the images to them. So I'm going to say, yes, create those. No, no, it's not. It's not telling me. I think the repositories are, I don't know, it's for free. I don't know. Yeah. Yeah, repositories are free. I don't know how much you pay for the data. They charge for space, but yeah, it's not much. So depending on the Amazon service, yeah. So our net seems to be decent here. So it's going to push the images to the repositories. And the next piece is going to be prompting me to create everything else that you saw in that other diagram. So while that's happening, if we go in here and we open up EC2 container service, we should see this is an empty container service, but here are the repositories. These are the ones that just were created. And we can see that the images should be popping in as they get pushed. So get back here. Maybe Redis is there. Something's there. Come on, guys. There's Postgres. Or no, sorry, that's the result app is there. So they're currently going. Does anybody have any questions while this is going on? Any other questions?
I saw the specified like max memory. Is there any concept in Docker where you don't specify that and it like dynamically allocates up into the max of the container or the host?
Good question.
We run into issues with like an import process will happen, consumes like twice the amount of memory, crashes the process.
Right.
Something along those.
I think you have to, I think you don't have to specify the memory reservation, but you have to specify the max zone. I think. I'm not 100% sure. Yeah. You're right. You're right. I had that backwards. Yeah. That's right. 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 That's right. Yeah. Had them reversed, but yeah, that's right. Mike's right about that. It won't place the container on the host if there's not enough space, so it won't allow that to happen. Yeah. Okay, so it's saying it's going to create 182 Amazon resources. So this is Terraform's way of saying, here's all the stuff I'm going to make. There's a lot of it. So if I didn't trust that this was going to work, I tested this yesterday, so I'm fairly confident it's going to work. I would want to go through here and see what the heck it's going to do before it creates all these resources. The only other kind of unique piece about this is I'm using spot instances, so it's going to start spot instances. So hopefully the spot prices are like low, so it can start them. We'll find out. Yes, I have yes to start creating it. So this is going to start creating it. So actually it has to kind of do the plan, then do the apply. But this is going now. So while that's kind of going, any other brainbusters? What's up? Okay.
Can you explain the responsibility of Terraform?
Oh, so Terraform is it's infrastructure as code in that like you specify, it's declarative kind of language for specifying resources in AWS. So you say, hey, I want this to exist in AWS. It compares what exists in AWS or what it thinks exists in AWS, and it's like, oh, this isn't here, I'm going to create it. So you declare all the infrastructure you want, and it shows up. And then it will keep track of the differing states. So as you modify your Terraform, it'll realize, oh, he changed something. I either need to rebuild this thing, or I need to modify it to make the state that exists in AWS equal to the state as I've declared in my configuration. Everything is in here. Yeah, everything's Terraform right now. This is only Terraform. So the provisioning of the instance, when it starts and it runs like a script, like Terraform's pretty powerful. Yeah. There's something called terraforming. It's like an open source project that you can point at existing infrastructure and it'll generate Terraform code for you. Yeah. It's not perfect. So, I mean, it's still kind of a pain in the butt, honestly. Yeah. Right, right, exactly. Yeah. They're competitors, yeah. So Terraform uses the AWS API, yeah. So it just uses whatever APIs AWS is currently exposing. So it's using some sort of AWS SDK behind the scenes. But the CloudFormation, it just uploads a CloudFormation template into AWS, and then AWS, however they do it behind the scenes there, I don't know. I don't know if they interact with their own APIs, or they probably have some sort of other hook that's like proprietary, specific to CloudFormation. So, right. Okay, so things are coming in now. We got a VPC, we've got our subnets, we've got our route tables, we've got our cluster has been started, and we can see all the task definitions for, this is for the containers that we started. So if I go into EC2, we have 3 running instances now, so, and we should have some load balancers as well that should try to start sending traffic once the container's deployed. So yeah, so we've got a voting load balancer, which is the application load balancer, which is path-based, and then we've got one for Redis and one for Postgres, because those are, in this demo, they're in containers. So the instances are initializing. So when this thing, oh, I lost my, here we go, come back here. Okay, when this is done, it should print out a link for me to go to, and I'll pop it in the console, and then once everything's healthy, the link will start working, and then we can go and vote, and we can see the kind of demo of it working. But what you guys, this demo is about is EC2 Container Service. So this is our view into EC2 Container Service on the clusters page. So this is showing me my cluster, and it's showing me some metrics about CPU and memory utilization, but currently no instances are registered. This means that the instances that are starting haven't yet said, hey, give me Docker containers. So they're not pushing any metrics, they're not registered, so it can't deploy anything yet. So if we go into the cluster, we have services. So over here you can see desired tasks. So I'm saying I want 3 result apps. These is the result web application. I want 3 vote apps. So it's going to be 1 per instance across different availability zones. And I want 2 workers, 1 Postgres database and 1 Redis message queue.
So it's a service wrap task.
Right, exactly. A service wraps a task. And it kind of does all the magic. So then you can actually, so if we click on a service, we can click on the events. So here are the tasks for the service. And you can see the events of, it's going to say like it's trying to deploy it. It is unable to place the task because no instance met all of its requirements. That means in this situation that no instances have registered with the cluster yet, so it can't place them. But that could also mean there's not enough memory on your cluster, and no one instance on your cluster has space for this container. Or it could mean you said, I only want you to be on instances or deploy this task instances that have this particular tag, and there's no instances with this tag. So it just means it just didn't meet any requirements, didn't find any instances that were available to deploy this task to. All right, so now we've got a bunch of running tasks, so that's good. Everything's running. All the instances are here, and we've got metrics coming in through this dashboard here. So if I go back to the cluster, hopefully we'll have 4% utilization of CPU and 0.08% memory. So some pretty heavy stuff. All right, so yeah, I've got a vote here, so I can copy this link. In this demo, I did /vote goes to the vote app. And then if I don't have, copy and paste the same link. If I don't have URL, that'll go to the result app. So right now it's 50-50, nobody's voted. And then the vote app. So the only piece is if I click cats, it should update the other one. So it should put a message on the queue. The worker should read the message off the queue, update the database. The database should then be queried by the result app, and it should get updated. If the workers, they take longer to start, so it might not work yet. So I click cats. Yeah, so that's working. So I'm the only voter. I've never tried other people like going here, so I don't know what happens. I've only done it with just myself. But that's ECS and working live right here. You can also drill down onto each instance. So here are the instances, and you can see which ones got tasks. So hypothetically, I can just demo one last little piece here. I got like a couple minutes. So I could actually go in here to my auto scaling group. Suppose I wanted to make it bigger. So I can just set the desired to 4. This should start another instance. So max is 3 right now, so I'm going to put my max to 4 as well so that I can actually do that. Okay, so that should cause the auto scaling group to spin up a new instance. that instance should be registered with ECS, and I can demo draining. So this is the piece where you gracefully scale down. Basically, as your cluster scales up and down, when it kills an instance, by default, it's not going to go and say, stop sending traffic to this instance first. Amazon's like auto scaling is stupid. It's like dumb as in like it doesn't interact with these other pieces. And so it'll just drop an instance. And so if traffic is being sent to that instance, they're going to be lost requests. So CloudWatch has hooks, and auto scaling groups have hooks, so that when an instance scales down, you can use that hook to drain the instance first before it actually gets terminated, so that you won't actually lose any traffic. So right here, we've got all active and draining. So currently, we have no draining instances. But once that instance starts, it should hop in here. But while that's happening, does anybody have any other questions? It's starting right now. Right. So there is definitely a disjointedness of how container scaling works and instance scaling works. They're both driven by CloudWatch metrics, but you can scale containers up and not scale instances, and you can scale instances up and not scale containers. And so you need to make sure, and you need to test and make sure that as your containers scale up, that you've got scaling policies in place on your instance that says, I need to add more instances so I have memory available to place these new containers. If you don't have scaling of your actual hardware, then you'll just scale up containers and it can't place them because there's no space, and then you're screwed. So there's totally separate policies, and they all actually operate independently. So you have to be really careful with the tuning of your policies, in that you can have scale down policies and scale out policies, and you could technically have both of them be true at the same time. So it could literally just start and stop an instance over and over and over and over again, because they're both true, and if they're like fighting one another. So you got to be you have to be careful with how you tune your instance and your task scaling. What's that? No, as far as I know, no. You just got to make sure you do it right. Like, just be careful. Yeah. Dang, good question. Weaknesses of ECS in particular. So I've seen, I haven't spent a ton of time using competitors. Like, I basically just researched them and just barely kicked them around or watched other people kick them around. But Kubernetes does have some pretty cool features with, like, it sets up a VPN automatically. It's like a bastion host, and it also acts as like a tunnel for like your incoming traffic, and it will only accept traffic from you, and then it will like kill that VPN right when you kill that session. It's got some pretty like sophisticated features for DevOps people, you know. Also, a lot of open source stuff like Kubernetes has, people have spent time developing open source interfaces and things like that go on top of Kubernetes that you can just like plug and play, and it's literally just like adding a couple lines to a file, and you just say apply it, and all of a sudden it all just works, and you have this like beautiful dashboard. Whereas ECS, like, you got what Amazon gives you, and that's what you got, you know. But on the same token, ECS is a lot simpler. Like, Kubernetes is just a more complicated solution. So it's just more effort to stand up, and there's more to maintain. But it is, I think, comparatively like more powerful. So I'd like to see Amazon offer more features in that area. You know, continue to integrate ECS with other AWS services, and continue to like provide more just usability features. I mean, honestly, this interface kind of sucks in my opinion. Like, I think it's pretty bad. You know, it's like okay, but it's not great. It's not like what you get with Datadog or some other like third party. Dude, I honestly don't know. I would say ECS is third. I'd say it's behind Docker Swarm and Kubernetes, and that's completely just, I'm pulling that out of my butt. But the reason why I'm saying that is because Amazon has such a huge market share, and people are just like, either trust Amazon services. And so I think a lot of people, rather than biting off Kubernetes or Docker Swarm, you know, they would pick up ECS a lot of the time. And I think that gives it a leg up against the other competitors like Mesos and some of the other ones like Mesosphere and what else. So, but I still think Kubernetes and Docker Swarm have enough momentum kind of behind them they're talked about it like conventions and all this kind of stuff way more, than ECS is. So it's kind of just, they're still kind of playing catch up. It just started. It's not as mature, honestly, as those ones are. So.
Are there any unique security considerations with this kind of architecture?
Sure. I mean, absolutely. One of the unique security considerations is this. Suppose you're deploying a bunch of containers and they're all going onto one host. All those containers have unique ports that need to be open. And you don't know what ports need to be open on what host until the container is already there. So the solution is you open up all the ports that all your containers need on each host, basically. That's the solution. Or the alternative solution is what we talked about before, whereas we use security groups are kind of these virtual firewalls, and you can say only allow access. So you could open up many ports, but you could say only allow access from machines that have this other security group. And so you're basically limiting any incoming traffic not to an IP range or a sitter block. You're limiting it to literally a machine that has this other security group on it. So that's definitely a consideration because you don't know where these containers, how they're going to be distributed. And so you kind of have to just open up all the ports that all containers that you're deploying are listening on, which one advantage is one thing you might want to try to do is just have, if they're all web services, then most of them are probably RESTful APIs of some sort, right? So you try to get them all on the same port, then it's simpler and it's a bit more secure, Yeah.
Are you aware of any security compromise where containers can access memory space for another container on the same system?
I haven't heard of memory space, but there's definitely security concerns with containers. One thing is Docker runs as root. So the containers it's running, so there's a ton of security concerns. One, people who write Docker images sometimes you don't specify a user, and if you don't specify a user in your Docker file, it'll run as root by default or whatever, unless you override it on the command line when the container starts. And then now you basically are running as root in the container, but you have root access, root privileges. So if that container gets compromised, it's compromised, potentially compromise the entire machine. The other piece is containers can be run as privileged, which basically means they're run as root. So you got to be careful never to run them as privileged. Always run your containers as a particular user. And a lot of times, one thing that's really tricky with Docker is when you mount a volume into the container to write to, it by default doesn't really have permissions to do that unless you run the container as root. Then it will obviously have permissions to write, which is bad. So what you have to do is you have to run it as a user, but you get in this really crazy situation where you have to, on the host file system, change ownership of the directory you're mounting into the container to the user ID of the user that's actually running in the container. So you'll see on your host file system, you're doing a list of with ls-l basically of that directory, and you'll see it's owned by no user. It's going to be just a user ID, and it's user ID 1000 and group 1000. But when it's in the container, that user ID of 1000 actually maps to a user. And so it's just a really bizarre, tricky, it's just messy, man. It's one reason why you really want to keep your container stateless and don't want to have to write to your local file system if you can avoid it. Yeah.
Would another best practice be to have containers with high sensitivity information be on a separate instance than those which may be processing general web requests?
Sure. Yeah. That sounds good to me. I think it's good to partition your containers and separate them based on security concerns. Absolutely. But I think I'm not an expert in container security. I'm still learning. So, but I would say that is a major concern and something that a lot of times gets overlooked. There's a lot of containers out there running in root that people don't know are running as root, and they have root write access and people don't know it. And it's easy to make that mistake, especially if you're a software engineer and you're writing your own Docker files and I'm just deploying them. It's my responsibility as a DevOps engineer to look at those and be like, hey, you messed up. This is insecure. But that gets overlooked a lot, I think. So that's basically the whole demo, the whole thing. I can drain the instance now, which is kind of cool. So this should show up. All right, so yeah, you just hit drain and then it's going to basically start draining connections to that instance so no new traffic comes in. And then it'll start, actually, I just drained the instance that had no tasks on it. Well, it would start moving the tasks to the other instance. My bad. So I just drained the one I just started, so I messed that up. But any other questions? That would work though. To drain it, you could do it through the AWS CLI. I don't think Terraform. Terraform is more command line interface. So like, what's that? Right, right. Terraform is definitely more for provisioning, declaring what your infrastructure is. It's not for like one-off kind of scripty kind of things like this. Yeah, I implemented a Lambda. So basically, when the auto scaling group decides to scale down, basically what it does is the hook that gets called, it calls puts a message on a SNS topic, and that message gets consumed by a Lambda, and that Lambda then drains the instance, and then it just checks back until the instance is fully drained, and then it removes, allows the auto scaling group to terminate. That's like I mean, I didn't like come up with that architecture. Like I found an AWS blog about it, and then I just did it, and I did it in Terraform, but even the code, the Lambda itself was provided by Amazon, so I just used their Lambda. Yeah.
What does that code look like?
It's Python. It's pretty lightweight. It was just a Python, had the dependencies wrapped up in it. It's deployed as like a zip file. You just put it in S3, and you configure in Terraform to look for the Lambda in this one location, and then it just creates it out of the S3 bucket. And if you update it, it gets updated, and that's how it works. It's pretty lightweight. Jason, you were about to ask something?
How does draining work? Basically, just remove that container from the balancer, or
Yeah, so it tells the load balancer to go to drain that container, which means no new traffic gets sent to that container. You have a draining duration configured on a load balancer, basically on what's called a target group level or a load balancer level. So a target group is saying everything in this target group, all the traffic gets split among these containers, right? So you would say, if I configure that target group to drain for 30 seconds, so when I put that in draining, it tells the load balancer to drain all containers that are on that instance. Those particular containers would drain for 30 seconds because that's what that load balancer is configured to do. It would stop sending traffic. After 30 seconds, it would just remove them from the load balancer entirely. And in that time frame, ECS has already decided it's in draining state. These are going to go away, so I need to move these containers to a new instance. So it's going to start shuffling them over and restarting them. So, any other questions? This is good, man. I didn't expect, when I was rehearsing at Home Alone, like nobody was asking me questions. I was just trying to anticipate. That's it?
wow.
Awesome. Thank you.